Hi, I'm Vijay Gill, AOL Time Warner. What I'm going to talk about is lack of classification ability considered harmful. The actual title on the printed agenda is a little bit off because I don't care if you have RP queuing capability on the RP. By the time you have gotten to the RP, it's already too late. So, but that made for a better soundbite, I guess. Okay, so there will only be two items on the slide. This is for the vendors. I know Barry's, there you go. Security. And we only have one item on the slide because we just want to get the message across and don't want to distract our vendors from this. 200 megabits attacks are trivial to generate. And the Internet machine gun could do this in 1994. And as we've seen, this is from the recent slammer worms. This is not out of reach for a single machine to do. And about half of this directed at a router in any current internet backbone will destroy the router. All these NIMDA attacks, all these slammer attacks will seem like a memory of heaven if these guys decide to take out the routers. I'm speaking slowly so people can understand this. 100 megabits per second attack directed at any router in the internet today, with the exception of perhaps Avicii, those guys who actually paid attention to this, will destroy the router.
Get the mic. It's not the megabits, it's the packets per second.
Right.
So it's actually worse than the megabits. So since you're speaking to vendors, and we got other vendors in here, you know, I know what problem I'm working on. It's not megabits, it's packets per second that whacks it. And so it's a lot easier than megabits per second.
Right, I'm just putting this out as a harder bar to...
So we know target the vendors should be working on.
Right.
Right. So others can work on this too.
Right.
PPS.
This is a symptom of the problem. So now we have seen what the slammer worm did. Now, assuming that the slammer worm had been coded by somebody more malicious, and all they needed to do was run trace routes from each infected host and then start directing packet streams at the far side of the trace route and work their way back. That would have destroyed the entire global internet in, I guess, 5 minutes. So this is the magnitude of the problem we are dealing here. Why this is so? Packets per second, bits per second, this is irrelevant. All this really depends upon is the attack point. The attack point is the connection between the line cards and the brain of the router. This is a bottleneck because there is no economical way to make a router that has as much bandwidth to the RP as it does through the box. You can always send more traffic to the box than the box can digest. What we really need, and this goes back to what Dave said earlier, is line rate decryption of packets at the line card level, at the port level of the line card. So we can quickly disambiguate good from bad. People will say, why don't we put on MD5 checksums for the BGP sessions? That is not going to help because the MD5 checksums in most implementations are decoded at the RP. In fact, having to deal with the additional load of the MD digest probably constitutes a DOS attack in and of itself. So basically, skipping all this, we just go to the root of the problem is that it is very hard to disambiguate valid protocol packets from invalid protocol packets without putting some sort of glue in the protocols and on the line cards. Attackers have attacked BGP, and the reason I bring BGP up is because this is the worst case scenario. If we can solve the problem for BGP, everything else almost essentially falls out for free. And in BGP, I put things like MSDP as well. Anything that has an external state that you need to communicate with a neighbor. So, the problem. We need some way to disambiguate between invalid and valid control packets, and those things are hard to do because it's very easy to generate what looks like a valid BGP update spoofed with a source address that you have, and then just shoot it at a router that shows up in a trace route. Some people say, why don't we rate limit control traffic? And again, that is not a valid solution because we can rate limit control traffic. The problem is that you can always send enough junk that you start losing legitimate updates. If you start losing legitimate updates, the router will drop adjacencies and go offline, causing a whole amount of churn, thus exacerbating the problem. I'm harping on BGP and MSDP because all the other traffic is not controlled traffic. I don't care if I miss a whole bunch of NTP updates. My router will be off by a couple of seconds at the end of the day, but it will not cause a major routing event or a routing data crash. So what we are looking for is simple, unambiguous parsing. Anything that is on the receive adjacency, like your forwarding adjacencies that point to the router itself, the route processor, we should be able to queue packets that go to the receive adjacency on the line cards, not on the RP. Everything that I deem interesting, that my classifiers have said, this looks like valid data, this looks like interesting data, put on the high priority queue. Everything else goes on the low priority queue. Now, Barry has mentioned that some of this work is being looked at, and I encourage that. This should go back directly to your hardware engineers. This should be engineered into your next generation line cards. I hope this message gets through. This should be engineered in because we are at a very vulnerable stage. There will be no comebacks from this if somebody decides to take a few whacks at the internet infrastructure. Now, how do we decide what's interesting to us? So, first thing is we can apply a discriminator or a packet filter or an ACL or whatever, what have you, onto the line card CPU. Cisco has an application called the Receive Path ACL, and that's a good start, but we need to expand on that some more. And ideally, once we have SSL decryptors or TLS decryptors on the line cards, the code should apply, is this a valid frame logic in the receiver? At that point, we should be able to decrypt our MD5 and see if this is a valid update. However, we are not at that stage yet, and I don't anticipate being at that stage yet, hence things like the BGP TTL hack, which are quicker workarounds while we work on getting TLS accelerators onto the line cards. IGP traffic can be safely blocked. As I've already mentioned, the problems with MD5 in current implementations, all the decryption is done on the RP, therefore it's too late already. So what we need is dynamic filtering on the line cards, and long term, we need decryption in the receive framers of the line cards. And every solution that we have proposed so far depends on the fact that you can have A, discriminators, and B, you have implemented priority queuing on the line cards. One answer, a quicker short-term hack, and this is somewhat implemented in Juniper, is the dynamic 4-tuple. You figure out who your configured neighbors are, and then you push down an ACL that says, only allow BGP packets configured with this source destination, and as an additional artifact, add in the ports that you've picked, depending on 179 will be either your port or your neighbor's port, depending on who won the BGP collision detection. If the packet matches the filter, place it into the high priority queue, else place it into the low priority queue. Now we are assuming that any valid BGP packet on the line card will have the right 4-tuple. And we are assuming that your sequence number generators for BGP port your sequence number generators, the same pool of entropy you pull for your ISNs, for your TCP sessions, is the same pool of entropy you pull to add, to get the ports for your source or destination, depending on who won the BGP collision detection. This is important. Current implementations just pick the next highest port available as the local port and then send out a BGP update. So which means that almost every session, and we've looked at our current established sessions and routers today, are mostly in the range of 4,000 to 6,000. This reduces the amount of space the attacker has to search to punch through a hole in your filters. Okay? So your software engineers, I'm speaking to you, Barry, You need to look at your ISN pool, entropy pool, and use that so you can actually have truly randomized source ports for your TCP sessions. Currently, they do not. So what does this do? Out of 64K ports, assuming the attacker is smart and can figure out how the BGP collision detection went, you now have 64,000 possible ports. Take out 1,000 for low-numbered ports. On average, which means that the attacker will have to search half the TCP port space to find the valid tuple. So that's about 32,000 ports. So 32,000 combinations to break the filter. So the cost to the attacker to attack a router has risen 32,000 times, but the cost to the defender is fairly minor. Stability is most important. We'll take time to reconverge or time to establish a new session over preserving current sessions. Preserve the current sessions first, then worry about turning up new sessions, because you have to put wildcards in some of these filters until the collision detection resolves. The future goals are, of course, BGP over SSL, TLS, whatever is the flavor du jour, line card filtering at the edges, BGP TTL hack. Somebody mentioned that iBGP would not work with this, and Dave answered that. You block your source loopback addresses at every external facing port. We do this today at AOL. The capability exists in routers now, perhaps after some upgrades on line cards for some vendors, but it is doable. We have done it, so a large global backbone can do this. It's not too expensive. Hopefully your loopback blocks don't change much, so that once you've eaten the cost of rolling it out to like 400 routers and like 10,000 interfaces, it's fairly static. So the BGP TTL hack applies the TTL as an input into the discriminator. Now the problem with this is that it is fairly easy if a router immediately downstream to you is hacked, you can rewrite the line card to reset TTL to 255 on everything that goes through the box. However, again, this is not a panacea that solves all problems. This is a short-term hack. What we are trying to do is raise the cost to the attacker faster than the cost to the defender. So now, things like the slammer worm targeted at the internet infrastructure will have a much harder time breaking in and hacking into routers in the path before a network under attack, and then destroying it than they would today. And again, packet filter, backbone space as a source on all ingress ports. This is doable. We have existence proof. Any questions?
So, some feedback for you. First, about the TTL thing on eBGP. I think with existing equipment, you can do that today. You can configure your eBGP to be multi-hop with TTL 255, and you can configure firewall filters that match source ports and TTL. So that should be it. That should be doable.
The issue is that we don't want to turn TTL into a negotiated parameter, because what that reduces to is that now it becomes a cookie and the attack space is reduced to 255. So we want an immutable number as opposed to a cookie.
No. What I'm saying is that you can put a firewall filter on the receiver, on the line card, that only lets BGP packets to the RE path if they have TTL 255.
Right.
So you can implement your TTL hack just by configuring the router. You don't need the router vendors to do anything. It's just a matter of configuration.
Well, on some routers, yes.
On some routers.
No, we want this as a standardized solution so that everybody implements this. We want to make a change in the protocol. You can have TTL 255 without disabling the connected check. And out of the three networks we looked at, Sprint, AOL, Verio, we had maybe less than 1% of people that had actually disabled. We had actually used eBGP multi-hop as a way of disabling connected check. So the vast majority of our sessions we can have TTL 255 and retain connected check.
So, but I guess the main point I wanted to make is that what you're saying is that, in an ideal world, you'd have the ability on the line cards to decrypt
At line rate.
at line rate traffic. That's going to cost you a lot. It might be looking at other kinds of networks, like for instance the telephone network, what they end up doing was put all control offline, separate data from control. It might be a much simpler solution to this particular problem, cheaper certainly, to just pretty much separate data and control traffic on a physical wire, and I guess we'll only have 56K for data and the remaining for control, but that will give you a much cheaper solution than requiring 10 gig of decrypt engines times 16.
Right. This has also historically been an artifact of the way the original ARPANET designers went through this argument. There were people back in the day arguing for separation of control and data, and the original designers thought that that was not a good idea. And we are reevaluating that, and essentially what we have with decrypted routing updates is that we have moved to an out-of-band control channel, except that the out-of-band control channel runs in-band. Because if you encapsulate all your control traffic into a tunnel, if you would, an IPsec tunnel or whatever, you have moved it to a out-of-band. But that requires more cost on the... Right. Yes, we are aware.
Owen DeLong, Tell Me Networks. When you were talking about determining interesting traffic, it occurs to me that your eBGP peers generally would have a limited subset, usually where n equals 1, of interfaces that they would validly be sending you updates on.
Correct.
So it might be good to include the interface in the parameters of determining interesting traffic, such that traffic from BGP peer A can't come in on interfaces BGP peer A is not attached to, and BGP peer A theoretically should be discarding traffic that arrives at him claiming to be from him.
Yes, that is definitely a good idea.
JI, AT&T Labs. I am not a rather hardware engineer. I'm a security person, and some of my alarms went off. Is it actually feasible to put crypto engines on the line cards, just so that I would love it if there were crypto engines that could do line speed, AES or whatever on the line cards, but is it really feasible?
Okay.
I guess I got my answer. And the observation about separating control and data traffic, I think would be great if we could just have the BGP sessions run over IPsec, not necessarily tunnels. They can be in transport mode if you care about the details, even with just authentication only. And that would solve a lot more problems.
Yes, that is one of the things I think I should mention it here. Is BGP over SSL or TLS is the eventual goal.
You don't want SSL TLS, you want IPsec.
Well, I mean,
we can take
some sort of encrypted
we can
transport.
take this offline,
we just picked SSL because, well, it's here, we can do it.
This is IPsec, of course. But yeah, talk to a security person about, or you have security person
right
there.
So those are long-term goals. Currently, short-term, we are wide open, and as we've seen, both, at least I know from Barry that Cisco's working on this, and I know Juniper's working on this. These are hacks we can put in within, like, say, the next 2 years, as opposed to working on changing the protocol to run it over IPsec.
You don't have to change the protocol.
Well, I mean, changing all the implementation stuff. That will be longer term. We will eventually get there, but that will take a little bit longer than what we currently have.
I don't see why you need to change anything in the protocol. It's just a different. It's an encapsulating protocol. You don't change anything in the protocol.
Okay.
with respect to doing IPsec in hardware, I think that, doing DES or any other cipher probably isn't the hardest part because there's off-the-shelf stuff. I think doing the setup to get keys and associations and all that will turn out to be some lookup cost, some memory, that sort of stuff. It'd be nice if you guys could quantify the number of security associations that need to be implemented in hardware. Is it 100? Is it 1,000? Those sort of things.
I can quantify that right now. You need one SA per BGP session, and since AES is such a large block size, you don't need to rekey for thousands of years. So you really need to set up your security associations every time the router reboots.
Yeah, my question means, are we going to use this solution for a lot of other things, just not BGP and MSDP? And that's what I'm questioning. So we need a number. I mean, do you want to, secure flows that are going into the router for other reasons, that sort of thing? Telnet SSH.
Well, those we
Multicast flows.
we filter on we don't allow outside access. I'm not too concerned about security of the flows through the router. I'm not concerned about security of the end user. I don't really care. All I really care about is hardening the infrastructure. Just the very minimum needed to harden the infrastructure. Everything else will fall out of that.
Vijay, can you go back to your the diagram, the box diagram? That one, yeah. So people kind of understand, because I think people are flipping back and forth especially when we talk about SSL and IPsec, and where things need to happen is before that pointer that says point of attack. Because of the legacy of how we do routing, that's the thing we got to attack, whether it's a distributed architecture or centralized forwarding architecture. Once you get to that point, if you do SSL onto RP, well,
right.
Then you got a decryption saturation attack. It's packets per second. Like I said, lots of little packets that look like BGP with SSL keys in there, and it'll go straight through that point of attack, and you still got the same problem. So where the problem set for everybody else needs to work on is you need to push it out. You need to protect that point. And you mentioned that, but it was kind of like
the second to last one on the slide here.
Yeah, and this is why you actually do want to do it with IPsec tunnels, because then the routing processor, which is where a BGP runs, is not going to see any of that. All it's going to know is that a packet that has been vouched for by the line card came in.
Yes, that's why we put it on second to last point on the slide. We are aware of that. Yes, thank you.
Right. So you cannot use.
So do you want the crypto on the line card because the pipe to the RP is too small?
Well, in current,
or can we just fix that problem too?
Current deployed architectures, how about that? This is the RP, line card to RP is the weak point. And with the huge amount of capital, I know we've got on the order of like $500 million plus already sunk. We're not going to be upgrading those anytime soon, especially since our accountants are pulling for like 5-year amortization time. So yes, we would want it, keeping a current installed base of on the order of billions in mind. We would want to do line card upgrades to get that. For future vendors, of course, there's much more flexibility available.
Right. I just want to make sure that we're trying to engineer kind of a system level solution here, and we may have multiple instantiations of solutions given kind of where you start.
Yes, and if your processor can actually take line card and not crash, that's ideal. Dave, any last comments? Okay then, thank you.